Thank you for your introduction. My name is Han from Kyoto in Korea. I am pleased to have this opportunity to introduce the floating photovoltaic plants, which can be used on the surface of dam reservoirs. From now on, I'll mention the floating photovoltaic system as K-Water's brand name Solus. As you can see the table on the contents, this presentation will be divided into two main sections. To begin with, I'd like to briefly introduce K-Water and its green energy business. K-Water is carrying out a variety of businesses specialized in water and energy as a state-owned company in Korea. For example, we specialize in water resources development, multi-regional and local water supply. We have also designed and controlled national industrial complexes and green energy generation plants, such as the Shiwa tidal power plant. In addition, KOT has used its expertise to design and implement a variety of overseas projects all over the world. K-Water is a green energy mecca. We achieved a total capacity of 1,332 megawatts in terms of green energy in 2012. Some of K-Water's key achievements in the field of green energy include the construction and management of the world's largest Shiwa tidal power plant, the world's first floating photovoltaic power plants on dam reservoirs, and 16 small-sized hydropower plants that were built as part of the Four Rivers Restoration Project. The total green energy capacity of Korea is 4,084 megawatts. K-Water is a leading company in the green energy business of Korea. For instance, K-Water operates hydro power plants with a total capacity of 1,070 megawatts, which accounts for 63% of Korea's domestic hydropower generation capacity. Now, I am going to introduce the floating photovoltaic system, Solus, today's main topic. K-Water is actively pursuing ways to cope with the global crisis caused by the depletion of fossil fuels and climate change. Now, we cannot stress enough the importance of green energy development. Through our endeavors, K-Water has found that photovoltaic power generation is more useful than any other clean energy resource. It is an infinite, clean, and ideal resource to replace the fossil fuels. However, a land-based photovoltaic power plant has some serious side effects. For example, it requires a large area and can lead to the destruction of forests and farmlands. K-Water has found an alternative to traditional solar energy methods by developing a new type of eco-friendly solar energy. It is the floating photovoltaic system, in other words, K-Water's Solus. Solus has been derived from K-Water's know-how in water resources management, with the expense of water in a dam and unchecked technology of water and energy. We have already installed the photovoltaic generation system on the water surface of dam reservoirs. The generating system consists of three components. Firstly, a floating system that is comprised of photovoltaic power generating module. Secondly, a mooring device that stabilizes the floating system. And finally, an underwater cable that transfers electricity to a substation. We are proud that Solus is eco-friendly and highly efficient. Firstly, Solus does not cause any damage to the environment, such as logging and deforestation. Secondly, the efficiency of Solus is approximately 10% greater than that of land-based on the cooling effect of photovoltaic module. Thirdly, green tide can be controlled because the photovoltaic module blocks the direct sunlight. Next, I will speak about the development process. K-Water initiated a 2.4 kilowatt pilot project in 2009, followed by a 100 kilowatt demonstration project in November 2011. And finally, K-Water installed a 500 kilowatt class commercialization plant on the surface of Hacheon multipurpose dam reservoir in June of last year. We will construct 8 megawatt class plant by the end of this year. The development process occurred in 3 steps, from pilot study to commercialization. We went through various trial and errors at the stage of the development, and finally achieved the world's largest commercial floating photovoltaic plant of 500 kilowatts. Here, the remarkable fact is that we can reduce construction cost for the 500 kilowatt plant by about $2 per watt when compared with that of 100 kilowatt plant. Now, let's take a look at the overview of 100 kilowatt demonstration and the 500 kilowatt commercial plant located at Hacheon Dam. Particularly, attention should be given to the structure of the 500 kilowatt plant. It is 100% aluminum. This means our system does not harm the environment in any way. The success of the 500 kilowatt commercial plant can guarantee viability and profitability in this system. As a result of the modifications, the total construction cost was reduced by 30%, and the total number of construction days was reduced from 23 to 5 days. Next, I'd like to cover the advantages of Solus. It is eco-friendly, stable, and does not corrode. Firstly, the floating photovoltaic module is made from eco-friendly silicon materials that contains no lead. The floating photovoltaic module has been strengthened and has become more durable as a result of systems upgraded level of resistance to moisture and water. This system can withstand corrosion and contortion, especially in case of heavy rain and flooding and strong winds. Secondly, we have designed the best floating system possible by conducting complete structural and flow analysis. The analysis was based on meteorological data collected over the last 20 years. This system is stable and is designed to withstand typhoons or high tides. The buoyancy tank was built using fiber-reinforced plastic. It does not cause any environmental damage. Thirdly, a multi-sink wire suspension method was used for the mooring system. Its anchor and weights can automatically adjust the height of the floating system according to the changes in the water level. This allows the floating system to withstand the maximum 40 meters change in the water level and 30 meters per second wind, thus guaranteeing the stability of the floating system against the severe storms. Actually, when the typhoon Balabian hit the Korean peninsula last year, its maximum wind speed was 34.6 meters per second. The stability and reliability of Solus was unaffected by the typhoon. Here is some actual video footage of the typhoon Bulaben. Next, I will provide the final summary of Solus benefits. The efficiency of Solus increased by about 10% as a result of the cooling effect of the photovoltaic module. From the comparison chart, you can see that the 500 kilowatt commercialization model is the most efficient. Next, I'd like to comment on the design of Solus. Here, we have a picture of two optimal place for Solus development. I'm going to talk about some points that need to be considered when choosing a reasonable site for Solus development. Firstly, the depth of the water should be more than 5 meters in case of the lowest water level. In this picture, the entire area inside the yellow line satisfies this condition. Secondly, the site needs reliable sunlight that is not blocked. As well, there should be no floating matter on the surface of the water in flood season. Thirdly, the site should be within a short distance of an existing power grid. Here, the 2 points satisfy all of 3 conditions for construction of a system with a capacity of 2.5 megawatts. The 500 kilowatt Solus is designed as a single section. When we set the conditions of design, we focus on ensuring that it could withstand wind speeds up to 30 meters per second. Actually, we took into considerable severe conditions such as typhoons and monsoons. This picture shows the final unit model. Each 500 kilowatt sections is composed of 46 units. As indicated in the picture, we choose the multi-single suspension method as the optimal mooring device. It is designed to automatically adjust to water level changes. Now, let's look at the construction process of K-Water's 500 kilowatt commercialization model. Firstly, we selected an installation site. Secondly, we assembled the system in temporary arrays. Thirdly, we assembled the 3 arrays into an integrated structure on the surface of the water. Then, the modules were set up on the structure. Finally, the structure and the mooring device were connected. Then, the underwater cable was connected with the substation. At least, the construction is complete. The video will display the actual construction process. Finally, I would like to conclude this presentation by explaining K-Water's future plans. K-Water will construct the second Solus of 1,007 megawatts at 12 sites in Korea by 2022. During this period, we will secure the world's best floating photovoltaic generation technology and improve related industries. K-Water will realize the dream of green growth through the development of